I greet you all and I hope we are all well. So as you can see, our today's topic is trigonometry. We have covered remainder in factor theory and we are done. So I've proceeded to trigonometry. So let's do trigonometry. Make sure you pay attention because I'm just going to teach about the basic thing that you need to know about trigonometry before we go further. So trigonometry deals with relations between sides and angle of a triangle. So it deals with the relations between sides and angle of a triangle. I'm not going to write it down here because in the exam you won't find question like what is trigonometry or define trigonometry. So I just want you to have a clear understanding of what trigonometry is. So trigonometry deals with the relation between sides and angles of a triangle. So this is what I mean. So we have a triangle here. So a triangle like this. Okay, so let's say this is A, and then this is B, this is C. So the relation that I'm talking about is this side. So if you have A here, so here we're going to have a small a, okay? Again, if you have B here, we're going to have a small b, which is the same as here, we have a C, and here we're going to have like a small c. So these are the relation that I'm talking about, okay? And what you need to know about trigonometry is Pythagoras theory. So Pythagoras theory is one of the relation that is found on trigonometry. So Pythagoras theory. So let's look at Pythagoras theory. So we have Pythagoras theory. Theorem. So this is a Pythagoras theorem. So Pythagoras, let me just write it properly. So this is a Pythagoras theorem. Okay, so Pythagoras theorem, which is this one, is the relation between sides of a right angle triangle. So Pythagoras theorem deals with a right angled triangle. So whenever you see a right angle triangle, Pythagoras theorem must come in your mind, okay? Must come in your mind. So let me give an example in Pythagoras theorem. So this is our example in Pythagoras theorem. Let's say we have a right angle triangle, okay? This is a right angle triangle, okay? Let's just write this properly. Where's the roof? Okay, sorry. So let's just write it properly. Yeah, so this is a right angled triangle. So on Pythagoras theorem, which deals with the relation between the sides of a right angled triangle. So it deals with a right angled triangle. Let's say here we have a B, as I said, here we have A, and here we have a C. Okay, so the formula for Pythagoras theorem is hypotenuse squared. So the what's this? When you multiply hypotenuse by itself, it must give you the adjacent squared plus this adjacent squared. So let me write it down. So this hypotenuse, which is the longest side, the hypotenuse is the longest side. So we're going to have c squared is equals to a squared plus b squared. So this is the Pythagoras theorem. So you need to master this. It's very important in both maths and additional mathematics. So this is the formula for Pythagorean theorem. Let's do one example on Pythagorean theorem. Okay, we do one example in Pythagorean theorem. So this is our example. We have a right angle triangle. So example, right angle triangle. Okay. Okay, right angle triangle. Here we have 4 centimeter, 4 meter, here 3 meter, and here we have a 90 degrees, which means that this angle or this triangle is a right angled triangle. Here we have x. So in our example, we have been taught to find the value of x. So find the value of x. So let's find the value of x. So how can we find the value of x? So remember, I've talked about the formula for Pythagorean theorem, which is hypotenuse squared is equals to adjacent squared plus plus adjacent squared. So this is the formula for Pythagorean theory. So for us to find the value of x, we need to do x squared is equals to 4 squared plus 3 squared, because x is our adjacent. As you can see, it's the longest side on our triangle. So we're going to have x. So here we're going to have x squared is equals to 4 squared plus 3 squared, which is this one. Yeah, so this is how we can find x. Hypotenuse squared is equals to adjacent, which is this one. So this is hypotenuse, this is adjacent, and this is adjacent. Here we have no opposite because we are not dealing with the angles. We don't have the theta, so we have no opposite. So this and this are both adjacent. So our formula is hypotenuse squared. You square hypotenuse, which will give you the sum of adjacent and the other adjacent both squared. Okay, so this we're going to do x squared is equals to 4 squared plus 3 squared. So let's proceed. X squared, it's x squared is equals to 4 squared, it's 16 plus 3 squared, it's 9. So when you add 16 plus 9, it will give you 25. 16 plus 9, it will give you 25. So x squared is equals to 25. So here we need to find, we're finding the value for x. So we're going to make x the subject formula. So how can we do this? So we can make x the subject formula by introducing a square root, because you know that square roots and squared, they cancel. So here, so let me another way you can write a square root is like this. A square root same as so let's say maybe we have 5 square root of 5, square root of 5. So this can also be written as 5 to the power 1 over 2. So this is what it means. So when you introduce the squared this side, so where we have x squared, so when we introduce the square root here, which would be like this, this is the same as writing as x squared multiplied by or to the power 1 over 2. So these 2 and this will cancel, hence we remain with x. So that's how we can make x the subject of the formula. So let's now introduce the square root. So we have x squared, we have introduced the square root, is equals to 25 squared. So x is equals to 5. So, but you know that the square root of the number is either positive or negative. But remember, we're dealing with the side or the distance. So there is no distance in negative direction. So this is the value for x. X is equals to -5. So this is how to find the angles or the sides using Pythagoras theorem. Let's look on another example, which is example 2. So let's do example 2. Example 2. Remember, we're dealing with trigonometry, and these are the basics thing on trigonometry. We're still on Pythagoras theorem. So make sure you follow attentively, because this is the foundation. And if you miss the foundation, meaning that you won't build where you are going. Okay? So let's do another quick example. So our other example is like this. Okay? So here we have a triangle. Our triangle is like this. Like this. Okay? And like this. So this is the hypotenuse. This is the hypotenuse. We have 6 meter here, 6 meter. We have x here. We have 10 meter here, and here we have 90 degrees, and we have been taught to find x. So remember, we can find x using the Pythagoras by the Pythagoras theorem, which states that when you square the hypotenuse, it must give you the sum of the adjacent and another adjacent squared. Okay, so here if you see here the longest side, remember the longest side is the hypotenuse. So here 10 is our hypotenuse, 6 is our adjacent, and x is our adjacent. So let's now proceed. So here we're going to have so here we're going to have 10 squared, which is hypotenuse. So hypotenuse squared is equals to, so hypotenuse squared is equals to adjacent is equals to adjacent squared plus another adjacent squared. So this is the formula. So here our hypotenuse is 10. So we're going to have a 10 squared is equals to adjacent, which is 6 squared plus x squared. So when we square 10, when we square 10, the answer is 10. So 10 squared means 10 multiplied by 10, a number multiplied by itself. So 10 squared, it will give you 100. So here we're going to have 100 is equals to 6 squared, which means 6 multiplied by 6, it's 36 plus x squared. Here, so here if you see, we want x. So how can we find x? So we can only find x by making it the subject of the formula. So how can we make x a subject of the formula? By collecting the like terms. So here we are going to collect the like terms. So we're going to have 100 minus 36. So if 36 goes this side, remember here it's positive, and when a number crosses the equal sign, its sign changes to its sign changes. So if it's positive, its sign will be negative when it has crossed the equal sign. So since here it's positive, so its sign gonna be negative. So here we're going to have 100 minus 36, which would be equals to x squared. So 100 minus 36, it's 64. So 64 is equals to x squared. Here you find the square root. So x is, what is the square root of 64? So here means that it's a number which can be multiplied by itself to give us 64, and this is 8. So this is 8. So I'm going to have 80. So this was the value for x. Okay, so we have done some of the examples on Pythagoras theorem. Let's now conclude to trigonometry ratios, trigonometrical ratios or trig ratios. Okay, so this was just an example to make you catch up. Okay, our main focus is on trigonometric ratios. So trigonometric ratios. So remember, we're dealing with trig. We are doing trigonometry. So we're doing trigonometry. So trig ratios is the relation between the sides and an acute. So the sides between the sides and an acute. Okay, so we know what an acute is, an acute angle. So an acute angle is the angle less than 90 degrees. So an angle which is less than 90 degrees is called an acute. So trig ratio is the relation between the sides and an acute angle of a right angled triangle. Okay, so that's what trig ratios are. So let's take note of this, because it would be needed as we go further. So is the relation is the relation is the relation so is the relation between the sides and an acute angle of a triangle. Remember, we're dealing with triangles of a triangle. Okay, so trig ratios is the relation between the sides and an acute angle of a triangle. So this is what trig ratios are. So the relation between the sides and an acute angle is called trig ratios. So let me just give you a diagram of a triangle and its part on trig ratios. So we're going to have a triangle. Okay, a triangle here. So we have a triangle. Okay, okay, so this is the right angled triangle. Okay, so in here we have 90 degrees. Here we have a theta here. So having this, let's now label the triangle on trig ratios. So the longest side, remember I said it's the hypotenuse. So this is hypotenuse. So this is hypotenuse, and the side which is opposite to the angle or the theta is called the opposite. Hear me clearly. The side opposite, which is opposite to the theta, is called opposite. So a lot of students get confused here on naming the adjacent and the opposite. They swap. So listen. So the side which is opposite to the theta or angle, it's called opposite. So here we have opposite. Okay, opposite, and the last one, it's adjacent. So these are the sides of a triangle near trig ratios. Remember, the longest sides hypotenuse, the sides opposite to the angle is called opposite, and the remaining one is adjacent. So adjacent opposite are hypotenuse. Let me also write another triangle so that we understand clearly. So it should be here. Okay, so it will be here. Yeah, so it will be here. So this one is like this. Okay, and here we have like this. So getting a distinction in additional mathematics is very simple. It's very simple. Actually, additional mathematics is one of the simplest subject. It's even simple compared to mathematics. Okay, though a lot of students be like, no, additional mathematics is very hard. It's very simple. It's very simple. So if you see at my what says the statement of results, if you see where's addition, here it's my additional mathematics, I got a distinction. So you can also get this distinction. You can also get this distinction in additional mathematics if you continue attending our lesson and studying. So just a matter of you attending the lessons and studying. Okay, so you can also do it. If others can do, you can also do it. So let's proceed. So this is our other triangle. So here we have a theta here. Here we have a theta. Here we have a theta. Here we have angle. So let's now just name the sides. So remember I said the sides that is opposite to the angle is called opposite. So you have opposite. The longest side it's a hypotenuse, and the other remaining side it's adjacent. So this is adjacent. Okay, so we have named the parts of a triangle on trig ratios. So now let's now look on some of the trig ratios. So we look at some of the trig ratios. Okay. Okay. So for us to clearly get what you're saying, let me just draw a triangle so that we can easily name the trig ratios. Okay. So we have a triangle. Sorry. We have a triangle, and this is our triangle. Okay. This is our triangle. Okay. And if you have any question on what we covered last meeting, you can send the question in my inbox. Remember, we are doing a remainder and factor theorem, so you can send in my inbox so that we do it together. Remember, alone you can try, but together we can do it. So I have a theta here. Remember, the longest side it's hypotenuse, adjacent. The other side is opposite because it's opposite to the theta. So this is our triangle. Okay, this is our triangle. Okay, and I believe you can also you can see it. So triangle. Okay, so let's now proceed to the trig ratios. So the following the ratios, the trig ratios. So ratios, the following are the ratios, and the ratio we have at first. So 1 is sine theta. So sine. So let me just write this with a blue marker so that you will see clearly. So we have sine theta. So sine theta is equals to adjacent. Sine theta is equals to opposite over hypotenuse. That's the ratio for sine theta. So sine theta is equals to opposite over hypotenuse. So of opposite, so this is the abbreviation for opposite over hypotenuse, which is like this, the abbreviation for hypotenuse. Okay, so this is sine theta. And so if we are finding one missing one missing angle or one missing side, we can use hypotenuse. So let's say if we have a theta, we can just replace where there is theta, we place with the angle, which will give us is equals to opposite over hypotenuse. To get your opposite, so in this case this is our opposite, this is our hypotenuse. Okay, so this is how you can do problems are using sine ratio. The second one, it's cosine or cos theta. So cosine theta or cos theta. So in abbreviation you can just write it as cos theta like this. So this is the abbreviation. There's no problem writing like this. Is equals to, so cos theta is equals to adjacent over hypotenuse. Make sure you master these things, master them, because in the exam they won't bring these things. They must be in your mind. So cos theta is equals to adjacent, which is this one, over hypotenuse. So adjacent divided by hypotenuse. Okay, so this is cos theta, and the other one is what's this? Is tan theta. Tan theta. So tan. So this is 2. This is 3. So tan theta. So tan theta is equals to opposite over adjacent. Opposite over adjacent. So this is tan theta, opposite over adjacent. Opposite over adjacent. So if you are dealing with ordinary mathematics, the trig ratios end here. So if you are doing ordinary math, the trig ratios end on tan theta. We start with sin theta, which is opposite over hypotenuse, cos theta, which is adjacent over hypotenuse, and tan theta, which is opposite over adjacent. So these are the trig ratios we have in mathematics. So remember here we're doing addition mathematics. So our trig ratios doesn't end here, but we proceed to cosec, which is cosec theta. So number 3 number 4 cosec theta. So cosec theta is equals to hypotenuse over opposite. So cosec is equals to so let me just write it this side so that I can give you another alternative way of writing these remaining trig ratios. So I have 4 here. We have cosec theta. So cosec theta is equals to hypotenuse over opposite. So hypotenuse over opposite. Okay, opposite. So it's like this. So this cosec theta, which is hypotenuse over opposite. So if you see cosec theta and sin theta, something that must come in your mind. These are almost the same, but they are just swapped. So here on sin theta we have hypotenuse down and opposite up, but here we have opposite down, hypotenuse up. So here this can be also written as 1 over sin theta. So cosec theta is the same as 1 divided sin theta. Okay, so you can also write it as 1 over sin theta. So this is important. This is, but because it's not always where you be letting right this. So cosec is the same as 1 over sin theta. So cosec is the same as 1 over sin theta. Okay, and our number 5 is secant or sec. Okay, we abbreviate it as sec. So it's a secant. So secant like this. So it's secant, but you can abbreviate it as sec. So write it as sec theta, which means secant. So secant or sec theta is equals to, so this should be a little down, a bit little down. So let's write it a bit little down here. So here 5 sec theta. So sec theta is equals to adjacent over hypotenuse over adjacent. Hypotenuse over adjacent. So of hypotenuse over adjacent. Okay, so remember, if you are if you are dealing with secant, is equal to hypotenuse over adjacent. Hypotenuse over adjacent. So this secant is also 1 over cos theta. So let's just prove that secant is 1 over cos theta. So we know that so let's write it as 1 over cos theta. So let's prove 1 over cos theta. So we know that cos is what's this? Adjacent over hypotenuse. So we're going to have something like this: 1 divide adjacent over hypotenuse, which is cos. So adjacent over hypotenuse. So remember, division sign changes into multiplication, and when it changes, the numerator becomes the denominator and the denominator becomes the numerator. So here we are going to have 1 multiplied by hypotenuse here, up hypotenuse, over down we're going to have adjacent. So when you multiply this, they'll give you hypotenuse over adjacent. So we have proven that secant is the same as 1 divided by cos theta. Okay, so this, and the last one is cotangent. So the abbreviation for cotangent is cot. So cot is equals to adjacent over opposite, or 1 over tan theta. So let me write. Okay. So tan or cot theta is equals to adjacent over opposite, or 1 over tan. So 1 divided by tan theta. So these are the trig ratios that we have. So we have 6 trig ratios. The number one is sine theta, the second is cos theta, followed by tan theta, cos theta, or cosec theta, sec theta, and cot theta. So these are the trig ratios that we have. So let's just do 1 or 2 examples on trig ratios. We know how to calculate the problems given using trig ratios. Okay, so let's do. So let's just create space. We just create space here. So make sure you have written this down. Okay, make sure you have written these down, because they will be needful where we are going. So we have so our example. So example. Okay, so our example, the first example, it says find the missing angle. So I've been told to find the missing angle. So find the missing angle. So we have here, find the missing angle. So let's find this missing angle. So let's look at the diagram which or where we need to find the missing angle. So where is that angle? So the angle is not unknown, but it's there. Okay. So remember to like and subscribe the video. And in case you have friends who are having challenges in additional mathematics, science, math, chemistry, commerce, civic education, and biology, you can introduce them to us. Remember, sharing is caring. Okay, so remember, sharing is caring. So this is our example. So here we have 90 degrees. 90 degrees we have 13. We have theta, okay, and we have 5. So these are meters. So these are meters. So here we have theta. Okay, so another one which is like this. Okay, it's like this. Okay. Okay. So it's like this. So this is the other angle. Okay, so this is the other angle. So here we have theta down. So we have theta, which is our angle here. Here we have 8 centimeter, we have 6 centimeter. So let's now find the missing angle. So the first thing that you need to do before you start your calculation is looking at the sides given. So first you take a look at the sides given and you identify the sides given. So if you see here in our first example, so this is example 1. Example 1. This is example 2. So if you see on the example 1, so let's write our solution down. So solution, solution. Okay, so if you see this triangle, let's identify the side. We know that what is this side? We know that the sides opposite to the angle is called opposite. So we have opposite. So our 5 here is our opposite. Again, the longest side, it's a hypotenuse. So you are going to see which trig ratio has opposite and hypotenuse. So if you see on the trig ratios that are here, though we have rubbed some. So here, if you see, so we have sine theta, which is opposite over hypotenuse. Do we have opposite this side? Yes, we have. It's this one. Do we have hypotenuse? It's this one. So here it means that sine theta can work. So let's try cos theta if it can work. So cos theta is adjacent over hypotenuse. If you see here, we have hypotenuse, but we don't have the adjacent. So that can't work. Same applies to tan theta, which uses opposite over adjacent. So we don't have adjacent, so we can't use these two trig ratios. So we can use sine theta, which is opposite over hypotenuse. So this is sine theta, opposite over hypotenuse. So let's do now. So here we have sine theta. Sine theta. Let me just write the answers. So I'm going to have sine theta, which is equal to opposite over hypotenuse. So class, what's our opposite? So our opposite, it's the side. It's the side opposite to the angle. So here is our opposite. So we're going to have opposite on top. So we're going to have 5 over hypotenuse. So hypotenuse is, so sine theta is equals to 5 over hypotenuse, which is 13. So let's do the calculation. So make sure when you're dealing with trig ratios, make sure your calculator is in degree or deg. Let me show you what I mean. So your calculator should be showing this D here. It should be showing the D here. So the D here means that your calculator is in deg. Make sure it's showing these. These. Okay, because if it's not showing this, it means that you are dealing with a secular measure. Okay, and you are going to get wrong answers. Okay, so let's now do 5 divide 13. So 5 divide 13, it will give us 0.38. So going to have 0.38. So we're going to have sine theta is equals to 0.38. Sine theta is equals to 0.38. Okay, so here let's now find the theta. So we can find the theta by making theta the subject formula. By doing this, so it will be theta is equals to, this sign will change into sine inverse of 0.38. Let's now find the value of sine inverse of 0.38. So how to punch on your calculator? You're going to punch shift. Remember, start with shift. We know why a shift is shift, then you click on sine. So you're going to have something like this. If you do this, you're going to have something like this. So remember, you start with shift, you click on shift, then you click on sine. So you're going to have something like this. Okay, then after doing this, so click shift, sine, open bracket, then put the 0.38 inside, 0.38. So it give you 22.3. So 22.3 was the value for theta. So theta is equals to 22.3. So this is what's the missing theta here. So here we have 22.3. Let's now do example 2. So example 2. Okay, so this is 1. Okay, and then 2 will begin here. So on our example 2, we have this triangle where we have 6 centimeter, 8 centimeter. So here, remember I said that the first thing that you need to do before you start your calculation it's to identify the sides given. So you need to identify the sides given. What sides are there? What sides are there? So after identifying the sides, then now you choose the trig ratios which you can use among those 6 we talked about, which are sine theta, cos theta, tan theta, cosec theta, sec theta, and cotangent. So let's identify what's given here. So if you see here, we have opposite, which is the side opposite to the angle. So we have opposite here and adjacent. So which which trig ratios deals with opposite and adjacent? It's which one? It's tan theta. So tan theta is opposite over adjacent. We have opposite here, we have adjacent here. So here we can't use sine theta because we don't have hypotenuse, and sine theta deals with hypotenuse. So here it can't work, even cos theta can't work. So let's now proceed. We've chosen that tan theta is the one which can work. So here we're going to have so tan theta. So tan theta is equals to tan theta. Sorry. So tan theta is equals to opposite over adjacent. So you should pass through these trig ratios. You master them. If you master them, I promise you won't be having challenges on trig. So trig is one topic that is ever in exam papers in additional mathematics. Apart from additional mathematics, even ordinary mathematics, it's ever there, and it carries about is it 5 marks if I'm not mistaken, but I'm sure it's 5 marks or 7 if I'm not mistaken, and the whole question there carries 12 marks there. So having identified the trig ratios that we're going to use, let's now look at the diagram. So our opposite here, it's 6 centimeter. So we have 6 centimeter, which is this one. So 6 centimeter. 8 is our adjacent. So 8 is our adjacent. So we're going to have a tan theta is equals to 6 over 8. So theta is equals to so tan theta is equals to 6 divide 8. 6 divide 8. Do 6 divide 8. So tan theta is equals to 6 over 8. So 6 divide 8 is 0.57. So tan theta is equals to 0.75. Again, here you do the same thing that we did. You take tan to that side. So we're going to have theta is equals to tan inverse of this one. So to do it quickly on a calculator, you can just do tan inverse of answer. Let me teach you how you can do this. Tan inverse of answer. So you just click on here. So without deleting your answer, so just here is our answer which we found. We found 0.75. So you just click on shift, then tan, and then you also click on answer, which is this one. So you click on shift, tan, and then you click on answer, which is this one, the ANS. So you click on answer and you click on equals. So it gives you 36.9. Remember, angles are rounded off to one decimal place. So 36.9 degrees. Remember to include the degrees because we're dealing with angles. So 36.8 0.9, yeah, 36.9. So 36.9. So today we have come to an end. So let me just give an exercise which you must submit in my inbox. Remember to answer your work on the paper, then you capture and send the picture to me, where I mark and give you the feedback. So let's just do one exercise. So this is our exercise. So our exercise is like this. So I'm doing trigonometry, and this is our task. So our task so our task says find the missing angle. It's just one question. Find the missing angle. So find the missing angle. Let's find the missing angle. Okay. So we have this. Okay, we have this. Okay. We have this and this line. This line here, we have a theta, and this is C. Here we have 11.5. 11.5. Here we have 17.5 meter. Even here it's a meter. So this is 11.5, this is 17.5 meter, and here it's A, here it's a B. Okay, so this is our exercise. So you need to find the missing side, which is BC. So let me just give the last task, or the last question. So this is the last question. Okay, this is the last question. We have a triangle. So here we have a triangle. This one. Okay, this one. So here we have 3 meter. Here we have 4 meter, and here we have x. So find the, so on this part you find the missing side, and then on this part, which is 2, so you find the value of x. So find the value of x. So this is our task. Remember to submit the answers in my inbox. Okay, have a blessed night till we meet again in our next meeting, where we proceed from where we have ended. Remember to subscribe, like, and study.